Hello, welcome to this webinar. My name is Renat van Kouder and I will host today's webinar. Last year, we introduced in a previous session Engilico's HyperScope solution for seal inspection of rigid packaging. Today, we will present the latest features of our HyperScope solution, and we will start with a short introduction of the system, followed by a number of use cases. In a nutshell, Engilico is a Belgium-based technology company founded in 2011. We have an enthusiastic team of 20 plus people with offices in Belgium, Germany and the USA. We are experts in inline seal inspection and help our customers to obtain better packaging quality, reduced packaging cost and increased packaging productivity. Our solution for flexible packages, called SealScope, is designed for 100% inline seal inspection and monitoring of flexible packages, such as pouches, pillow bags, and flow bags. Currently, we have over 220 installations worldwide, mainly in food and pet care industry. Our newest solution and topic of this presentation is HyperScope for seal inspection on rigid plastic containers such as trays, pots, and other thermo-formed packages. The incentive to develop a seal inspection solution for rigid containers came actually from our own customer base. Next to flexible packaging, a lot of our customers also produce in trays, pots, and thermoform packs, and they experience similar sealing challenges as with their flexible packages. Additionally, the use of rigid containers is very widespread, and in certain countries it is even more used than flexible packaging. So what are common sealing problems? This image shows a typical example of a thermoform package used in the food industry, containing fresh ham, packaged under modified atmosphere conditions. As you clearly can see, it has a sealing defect, which led to an open seal, which in turn led to spoiling of the product. The main root cause for open packages is product or other contamination in the sealing area. If such packages slip through quality control, this leads to reduced shelf life, food safety problems, customer complaints, return or callback action, and brand damage. In any case, this is always resulting in high costs. So one message: important to avoid. So inline seal inspection is very important, but this has its challenges. As today many food producers use printed films for attractive looking packaging, this makes it harder to see if there's any contamination in the sealing area. Also, in the case of transparent films, there may be too little contrast between the contamination and the film. For example, in case of water or fat. And the high production speeds don't make it any easier. A consequence of high production speed is that packages are not always nicely aligned on the conveyor, which makes it difficult for vision systems to recognize the exact boundaries. These challenges are hard to tackle with standard QC methods like manual inspection or industrial vision cameras. And when considering X-ray for seal inspection, there is not often enough difference in density between the contaminant and the packaging material. So there is a clear need for an automated, non-destructive, fast and inline inspection solutions for applications with printed film or applications with low contrast inclusions. Hyperspectral cameras can tackle these challenges. Unlike standard vision cameras that only capture information from the visible spectrum, hyperspectral cameras record images in a much larger bandwidth, in the visible and near infrared domain. Each material absorbs and reflects a certain amount of light in function of the chemical composition and wavelength. Hyperspectral cameras measure the reflected light and make a spectral profile for each measured pixel. The longer wavelengths penetrate plastic films, and so if there is a contamination in the sealing area, it will absorb more light than in case of a perfect seal, where no contamination is present. This makes it possible to distinguish inclusions when using printed film and in low contrast situations. This spectral profile, for example, allows to clearly identify fat and water in the seal. The solution we present is HyperScope. a hyperspectral camera-based system for seal inspection of rigid packages. The main advantage of hyperspectral imaging is that it can differentiate materials with a much higher contrast compared to standard vision cameras, and that it can also see through most printed films, what standard cameras can't do, thanks to the longer wavelengths of the near-infrared spectrum. HyperScope is an inline system that is able to inspect up to 160 packs per minute. For detailed seal area detection, it uses AI-based algorithms. And with an integrated conveyor and optional rejector, it can be easily retrofitted on your line. So let's see how the system is built up. The system consists of the hyperspectral camera, dedicated lighting, a multifunction operation panel, and a GPU accelerated controller with analysis software. The system is of course made of stainless steel and washdown proof in order to operate in food production environments. It is delivered with its own conveyor belt that can be configured to the customer's needs. If a package with a contamination is detected, it can be rejected by the optional rejection unit. We will now see a demonstration video of HyperScope in action. This demonstration of HyperScope shows an example of seal inspection on trays with chicken salami. Some of the packages have a contamination such as a small part of meat in the seal. Because the film is non-transparent, the contamination is not visible to the human eye or to a vision camera. HyperScope software automatically identifies the sealing area, which is displayed in green. Contaminations are shown in a different color. When a defective package is detected, a signal is sent to a rejection unit that removes the bad packages from the line. The seal inspection is a combination of camera technology and intelligent image processing. The first step of the image processing is to recognize the position of the package on the conveyor belt, as the orientation of the trays can slightly differ. Here, artificial intelligence is used to recognize the orientation of the package. Secondly, as we only want to inspect the seal, this area is determined by AI for analysis on contamination. Thirdly, we make a classification per pixel if it contains contamination or not. And finally, we need to decide whether or not to reject the package. Typically, you want to reject a package when the contamination exceeds a certain size or when it crosses the width of the seal. In the picture, we see three different contaminations that need to be interpreted. The large contamination on the bottom is considered too large and the pack is rejected. The other contaminations are too small. This criterion on rejection or acceptance of the package can be set by the customer. We mentioned already the use of the AI algorithm, so we will explain why this is needed and beneficial. Packages are not always arriving at the inspection station in ideal conditions. They can have a slight rotation, or there might be different variations of packaging films. Also, trays can have multiple compartments, so it's important to detect all sealing areas. To correctly extract the sealing area, AI is used. The benefit is that after an initial training, the algorithm is able to retrieve faster and more precise the sealing area. Also, the algorithm will continuously learn to recognize more different situations. Here are some examples on how the AI algorithm precisely extracts the sealing areas. In example 2 and 3, the packages have different orientations, but the sealing area of the package is automatically identified. We will now move on to real-life cases. Specific elements of all these cases are that the products are gassed, subject to degradation, have a challenging packaging, or where producers want to automate end-of-line and reduce manual inspection. In the movie, we already saw an example of salami packaged in a tray with printed foil. This example is a package of dried ham. The sealing area can contain both meat and fat, which is not visible under the printed foil. Also, the ham and fat have little contrast with the plastic tray. The hyperspectral camera allows you to distinguish both the meat and fat with much greater contrast as it has a different composition. A second example is sliced cheese in a transparent package. Here you can see the mold effect of a small leak that was also detected by the hyperspectral system. A next example is a duo package with bacon. As the bacon parts are greasy and sticky, often there remains contamination in the sealing or in the bridge. For systems that use transmission lighting, it is a challenge as the canyon between the packages is narrow and subject to undesired shadow effects. With hyperspectral, the product is lighted from the top and the contamination is clearly identified. An example that is not a meat application is the packaging of snacks. The printed film makes crushed crumbles difficult to see in the sealing area. Here, the example again shows crushed snacks that can lead to leakage or unsellable products. This is clearly identified by the hyperspectral system. Next applications are using cardboard bases, today often used to reduce plastic waste. In these cases, transmission lighting, which is often used by standard vision camera systems to enhance contrast, is definitely not usable. Hyperspectral offers here a solution as the light sources and the camera are mounted above the samples. Again, contamination is easily detected. Another example with a cardboard base. The sliced cheese in the seal prevents the proper closing of the package. Cheese under the printed top foil is detected by the HyperScope system. In the first example, it is difficult to distinguish pepper grains from the printed base. The second example shows clearly squeezed meat in the seal. And the third illustration shows the presence of water in the seal, which is invisible for the human eye but visible for the hyperspectral system. Also, when using aluminium trays, here filled with potatoes in sauce, hyperspectral can be used to retrieve sauce contamination in the seal. Important here is that hyperspectral can distinguish between light reflections and seal contamination. Beside printed film applications, HyperScope can also visualize contaminations with low contrast. In this example of a guacamole container, there is no visible inclusion in the sealing area, but you can see that an air leak has spoiled the content. With HyperScope, the contamination that allowed air to enter the package becomes visible. A final example presents how hyperspectral imaging can also be used, next to seal inspection, to determine if opaque packages are filled or empty. So let's continue to the benefits of hyperspectral imaging. So, to summarize, HyperScope is a great solution for non-destructive, inline and 100% seal inspection of rigid, plastic and cardboard packaging, allowing you to detect contaminations through most printed film, allowing you to detect contamination with low contrast that typically is invisible for regular vision cameras. The technology is driven by AI for precise detection of the sealing area and contamination, and both applicable on new and existing installations. The benefits are clear. It improves the outgoing packaging quality, enables you to do end-of-line automation, eliminates manual inspection, and reduces product returns and scrap. This brings us to the end of our presentation. If you have any questions, please let us know. We also want to mention that we are still offering free tests on your own samples. Simply contact us by phone, send an email to marketing@engilico.com or fill out the request formular on our website. After the webinar, there's also a short evaluation that you are invited to fill out. Thank you for your attention.